Hi guys, this is the Innovative Minds tutor, Mr. Richard. Right, we are going to look at exponential equation, grade 11. Right, let's get started, guys, without wasting time. Let's check here. You are given 27 to the power of x, which is equals to 1 over 9. Right. Remember, this is the golden property that you need to know. The golden property. When a to the power of y is equals to a to the power of x, then y will be equal to x, or x will be equal to y. So ensure that the bases from the left hand side and right hand side are the same, then you drop the exponent. Right, let's do the same thing even here. We can see that the bases are not the same, but we can see that we can change 27 to exponential form. When you change 27 to exponential form, 27 is the same as 3 to the power of 3 to the power, okay, 3 to the power of 3 and x, right? So what about 1 over 9? It might be tedious to work with to change 1 over 9, but it's not. Consider this. 1 over 9 reminds us of this law. Let's say I'm having 1 over a to the power of m. I want to change this into a negative exponent. It will be a to the power of negative m. Similar approach happens here. We are having 1 over 9. We can change 9 to the exponential form. It will be 3 all over 2. To a negative exponent, that will be 3 to the power of negative 2. So similar approach, we are going to do the same thing, right? So now what are we going to do from here? When we are here, 3 times x, right? Remember, these are the laws of exponents. 3 times x, it's 3 to the power of x, as well as 3 to the power of negative 2. So what happens here? When the bases are the same, we drop the exponent. We're having 3x is equals to negative 2. So our aim is to make x the subject. So x is equals to, what are we going? It's equals to what? We are going to make x the subject. So we are going to divide both sides by 3. So when we divide both sides by 3, we are left with negative 2 divided by 3. So that's the solution, right? Okay. Hope you've learned something from the first example. The second example will be to change 125 into prime bases. Yes, right, is to change, yes, using the laws. How do we change 125? When you change 125 to the power, when you change 125 to an exponential form, that will be the same as 5 to the power of 3. 5 to the power of 3, it's the same as 125. So an x here. Then what about 25? 25 will be 5 to the power of 2. X minus 2 equated to 1. So from here, we are going to use the laws of exponents to get rid of brackets. 3 multiply this exponent multiplied by the power will give us 5 to the power of 3x. Similarly, even here, 2 times x, that will be 2x. 2 times negative 2, that will be minus 4, equated to 1. The bases are the same. We add the exponent, that will be 3x plus 2x minus 4, equated to 1. So from here, what we could do, we can see that they are like terms, right? They are like terms. So 3x plus 2x, that will be similar as 5x minus 4 equated to 1. So we are not done, because we need to ensure that the bases are the same here. The bases are the same. So to ensure that the bases are the same, we need to write the number 1. You need to write this number 1 in a prime basis. How do we do that? We are going to use a definition of exponent. Let's say I'm having a to the power of 0. I'm always going to get 1. Any base that is powered by 0, that's going to be 1. So to make life easier, we need to put 5 as our base to ensure that the bases are the same. So 5 to the power of 0 is also 1. So in this case, instead of putting 1, we are going to put now 5 to the power of 0. So the same remains the same, 5 to the power of x minus 4, which will be 5 to the power of 0. So the bases are the same. What do? We drop the exponent. 5x minus 4 equated to 0. Then what do we do there? We take minus 4 to the right hand side. Since it's negative, it changes the sign. It's the same as 0 plus 4, which is equal to 4. Then to make x the subject, divide both sides by 4. Divide both sides by 5. I mean not 4. Divide both sides by 5. Then x will be equal to 4 all over 5. So that's how you can work out the second example. Remember, the first thing we did there is to change this into exponential form. Then we apply the laws of exponent. It's all about knowing the laws. When you know the laws, then you will never go wrong. Right, let's go to our last question. Right, when you're given such exponential equation with addition or subtraction, this reminds you of this law of exponents. Remember the law that says when the bases are the same, you add the exponents. It's the same law that we are going to use here, but we are going to use the reverse part, which is this, because we are given the reverse part. When you are given the reverse part, such as a m plus n, you split this into prime. You spill these bases using this law. You spilled these bases using this law, right? So this law is very important, guys, to take note of. So what are we going to do? Let's spill the bases. We are going to have 3 to the power of x and 3 to the power of 2 plus 3 to the power of x multiplied by 3 to the power of 3. Already this one is spilled, so there's no need for us to spill it. Then we have 315. There's no need for us to spell 315. Then the second step will be to take out the highest common factor. What is the highest common factor? We can see that's 3 to the power of x, guys. Highest common factor. So you factor out here. You are left with 3 to the power of 2. To get to 3 to the power of x, you need 1 multiplied by 3 to the power of 3. To get to negative 3 to the power of x, we need what? Minus 1. You can multiply it back. You will still get the same thing, right? So let's work out that step is to work out what is inside the brackets there. So 3 squared, that is 9. 3 squared, that is 9, and 1 times 3 to the power of 3, that is 27. Then we have 9 plus 27. I know that will be 9 times 27. That is 36, right? And 36 minus 1, what is that? That's 35. Okay? Equated to 315. Then we divide both sides by 35. Because we want to make 3 to the power of x a subject of the formula. So when we divide, we get rid of this. How many times does 35 goes into 315? It goes 9 times. So that will be 9. Then the bases are not the same. We need to change 9 to exponential form. It will be 3 to the power of 2. Then we have 3 to the power of x. The bases are the same. You drop the exponent. X is equal to 1. Right, guys. Hope you find this video useful, and don't forget to subscribe. And remember, we love you.